All right, let's do the electron configuration test review together. We'll just get started. It shouldn't be that lengthy because there's only 2 pages. The P sublevel represents the dumbbell shape. Okay, so remember this shape, okay, or that. All right, and they can also have different orientations, x-axis, y-axis, and then z coming at you. All right. Atoms that have the same number of electrons are blank with each other. You guys should know this by now. Isoelectronic. Electronic, if I can spell. Okay. Atomic orbitals can hold 2 electrons at most, and they must have opposite spins, is known as the Pauli principle. So this is one of our rules. You need to know all of these. Okay. A method that indicates the arrangement of electrons in a particular element is going to be the first thing we learned. Electron configuration. It's just the arrangement of the electrons. Electrons closest to the nucleus of an atom are highest in energy. Oh, I'm dumb. It's opposite. Lowest in energy. And so basically what that means is you have this nucleus, and if you have energy levels, okay, this will be the highest, EST, and these will be the lowest. I did all the videos in one day, so I'm kind of tired. This is the same day that I did all the others, so this is the lowest energy, it's the highest energy. The N equals 2 energy level contains these sublevels. So the second energy level, this one, remember it has an S and a P energy sublevel. Okay, moving on. The S sublevel represents this type of motion or shape, and that's the sphere. Okay, remember, sphere. Okay. Elements lose or gain electrons to become more like this group of elements. So remember, everybody's trying to be like these cool kids in group 18 right here. Okay. So those are called, where am I? Noble gases. The N equals 4 energy level contains these sublevels. So the fourth circle, 1, 2, 3, 4, that's going to contain everything. So remember, it has an S and a P and a D and an F. Remember, F's sublevels start at 4, okay? So it'll contain S, P, D, and F sublevels. A blank is the average distance of the electron to the nucleus of an atom. Average distance of the electron to the nucleus of the atom. That's N, the N, or the N is called the principal energy level. Okay? All right, moving on. Write the complete long-form electron configuration and include how many valence electrons there are for each of the following. So we have gallium. Gallium is here. So long form, that means, unfortunately, we have to start at hydrogen. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p1. Okay? So we're just going to write that. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, sorry, and then after 3d10, it's just 4p1. I think I may die. 4p1. Now it wants to know how many valence electrons there are. So to determine valence electrons, remember you look at the highest energy level. There's 1, 2, 3, and then 4. So 4 is the highest energy level. We have 2 of them. So when you have more than one of the highest energy level, you add the electrons, and that's how many valence electrons you have. So the 2 plus 1 is 3. Quick maths, okay? Okay. This one. Let's do the long form electron configuration for, I think that's IR, iridium. You're probably looking at it saying it's right there, stupid. There it is. Oh, nice. It includes an F1. All right. So iridium, IR. So, okay. So IR, we're just going to go for it. 1s2. We're going to go all the way to, this is 3, 4, 5D, 1, 2, 3, 4, 5, 6, 7. 5D7, I believe. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2. Okay, so we are now at 5s2. There's no F block yet, so we're going to go to 4d10. 4d10. And then we jump back up to the 5p block, 5p6. This is 2, 3, 4, 5. After 5p6, we go to 6s2. And then the F block. So 4f14. Remember, the F can only hold 14 electrons. So 4f14. And then 4f14, and then this will be 3, 4, 5d, 5d, 1, 2, 3, 4, 5, 6, 7. Remember, one of the electrons from the F block kicks back up to the D block. So 4d7. I'm sorry, 5d7. And that's it, okay? Now we need to find the highest energy level. 5, 4, 6, that's the highest one, okay? So 6 is the highest energy level. There's 2 electrons, so we have valence electrons equals 6. Can y'all see? Valence electrons equals 6. It is not 6. I'm so sorry, I'm tired. It is in the 6th energy level, but there's only, I even circled it. Valence electrons equals 2. Did I do it right here? Okay, good. All right, so valence electrons is 2. It's in the 6th energy level. Okay, write the orbital notation for each of the following. So we're just going to write orbital notation. On the test, I will not tell you the difference between electron configuration and orbital notation. Don't say, Miss, is this the one with the circles? You have to know that. If you don't know it, you do not deserve as much credit as the kids who do. So make sure you know what orbital notation is. Make sure you know how to do it. Make sure you know what electron configuration is. Make sure you know the difference between long form and noble gas configuration, because you will get all the points wrong if you did the noble gas configuration here, because you did not read the directions when it asked for long form. So please take that as a good warning. Make sure you follow the directions, okay? Okay. Orbital notation for each of the following. Be sure to label your sublevels. So sublevels, that means like 1s, 2s, 2p, or whatever. All right. Orbital notation for each of the following. So oxygen. Oxygen's here. That's an easy one. So we have a 1s, a 2s, and we have 3p. I'm sorry, 2p. Okay. So we have a 1s, and we have a 2s, and then we have a 2p. Okay, now we just fill in the arrows. So we have 1s2, 2s2, and oxygen is 3p1, 2, I'm sorry, 2p1, 2, 3, 4. So we have 4 electrons to fill in. 1, 2, 3, 4. Okay? If you did this, you get no credit. That's super bad, okay? I will not give any partial credit for that, okay? So make sure you know that's one of the rules. That's one of our rules. You must fill each sublevel first with 1 electron before the second one goes in. All right, scandium, where is that? I am like so tired and I cannot find anything anymore. Scandium, let's see. There it is, okay. So let's do orbital notation for these. So we have a 1s, a 2s, a 2p, 3s, 3p, 4s, and a 3d, okay? Let's do blue. So we have 1s, 2s, 2p, 3s, 3p, 4s, 3d. Okay, so we have those, and we'll draw our circles. So 1s, 2s, 2p, 3s, 3p, 4s, and then 3d. Okay, and we'll do our arrows. Okay, so scandium has 21 electrons. Okay, so 1, 2. You do it this way because you fill it up for each sub-level, okay? Don't go all the way here and then here. That's also a way you can get it wrong. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Okay, so that's how you fill it out. If you were to have filled it straight out, you'd have an up arrow on all of these, and then like a down arrow on like only a few of these. So make sure you fill up 1 up arrow for each sub-level first, and then do your down arrow. So you fill it out exactly the same way I did. All right, moving on, noble gas abbreviations to write the electron configuration for the following. So now they want noble gas abbreviations. So now we can do it in short abbreviated writing, whatever. Radium, here, okay? So radium, wow. I'm glad we're doing it noble gas configuration. So radium, we're going to go up into the most previous noble gas, which is radon, Rn, okay? And then from radon, we just go to radium. So radon, and then we go to 7s2. That's it. And then Sm, I think that's an samarium, okay? Whoops, here. So samarium, remember this whole line, you can kind of assume it's right here. So here, you go up into the most previous noble gas, which is xenon. So it will have xenon, okay? And then from xenon, we go to 6s2. So 6s2, and then the F block, 4f, 1, 2, 3, 4, 5, 6, 4f6. There will be a different way later if you do decide to be a chemist when you grow up, but we're not going to talk about the F block, how things kick back down to D block. We're just going to do it the way I did it. Just know if you do decide to be a chemist, you will see something different with the F electron configurations. All right, so that's the first page, super easy. The second page, we're going to do electron configuration for ions, And then we do identify the ion based on electric configuration, and then some quantum numbers questions. Okay, so write the long form, okay, not the noble gas abbreviation, the long form electron configuration for each of the following ions, and tell which noble gas it's isoelectronic with. So iodine is right here, okay, so that's 2, 3, 4, 5, P5. So we stop it at 5p5. I like to do neutral ion first, and then, I'm sorry, the neutral atom first, and then add the last of it. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10. Is it 4, 2, 3, 4? Nope, it's 5. 4p6, 5s2, 4d10, 5p, and 2, 3, 4, 5p5 is iodine, so it stops at 5p5. Okay, now I'm going to look at its charge. So iodine with a -1 charge, you're going to do the opposite. Add 1. So this is a -1 charge. You're going to add 1 charge. Okay, so now it'll be all of this the same, except at the end, I'm not going to rewrite all that. It's going to be 5p6, okay? So 5p6, it's isoelectronic with 2, 3, 4, 5p6. It's isoelectronic with xenon. Sorry guys, I like spit all over here. Or maybe it's snot, I don't even know. Okay, calcium with a 2+ charge, okay? So calcium, we'll just go to 4s2, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So we're there. Now we want to add, well, the charge is a +2 charge. Okay, so we're going to subtract 2, which means we actually get rid of this, okay? It cancels out that energy level. So 3p6, so we're looking at what it's isoelectronic with. 3p6, this is 2, this is 3p6, so it's isoelectronic with argon. We're using America's Cuddlers because America is great. Beryllium, oh. Popo, it's all the way down. Beryllium is here. 2, 3, 4, 5. So it's 5p. It's right in front of iodine. So we're just gonna get started. 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2. 4d10, 5p, 1, 2, 3, 4. So 5p4. Beryllium has a -2 charge, so that means we're going to add 2 at the end, which will make this 5p6. 5p6, it would be isoelectronic with xenon. Okay, now we did the opposite sign to find, we know the ion and we found the electron configuration of that ion. Now we know electron configuration and we need to find the ion. So here we keep the, what's it called? We keep the sign. So if it's neutral, we're done. 3p5. 2, 3p5, it's chlorine, okay? We're just going to write chlorine with no charge because it's neutral. 3p6 with a -1 charge. So all you do is take this and do it to that. 6 minus 1. So it's 3p5. Again, 3p5 is chlorine, but now it has a -1 charge. Okay, 3p6, so we are still at argon, but this ion has a -3 charge. So we're going to subtract 3, so that's actually 3p3. So let's look at 1, 2, 3, so that should be phosphorus, but with a -3 charge. Okay. These are a little easier because you don't have to write the electron configuration. So we have this 4p6, 2, 3, 4p6, so it's krypton, but with a +1 charge. So you add a 1, so it's 4p6 and then 5s1. Okay, we added that charge here. 5s1, so that should be potassium. Nope, I got crossed at krypton. Not potassium, rubidium with a +1 charge. Okay, and then we have not an electron configuration, but an orbital notation, and that's basically the same thing. So this X represents an up arrow and a down arrow. Hopefully you're watching this video and not just copying off of somebody, because if you are, you won't know that, and you're going to try to ask me, and I'm not going to answer this question on the test. But if you see an X, that just represents an up and a down arrow. So it's basically 1s2 with a +3 charge, so you're going to add 3. So it would be, that would mean it's 2s2, so that's, we need one more, and then 3p1. So 1s2, 2s2, and 3p1. So 3p1 is 1, 2, oh, is it? 1s2, 2s2, 3p1. Boron with a +3 charge. Oh, yeah. That makes sense. Okay. So 1s2 with a +3 charge boron. Okay, I'm okay with this. That's why I'm confused. So that's actually a 2. Name the element described. These should be very easy. Okay, so 5p4, you go to 2, 3, 4, 5, p1, 2, 3, 4. That's beryllium or whatever. Te or tellurium. Tellurium. Sorry. Okay, next we are going to look at this one. Name the element. So we know it's in the 5th sublevel, okay? So we know it's 5. 2, so remember S equals 0, P equals 1. These are quantum numbers. Do you remember those? Those are quantum numbers. P equals 1, D equals 2, F equals 3. This is 2, so it's 5D. And then remember the D has 5 orientations. So 5D. And then, so, sorry, this is 3D, 4D. So it's somewhere here. It's one of these. Okay, so what I'm going to do is label each of these based off of this. So that's -2, -1, 0, 1, and 2. Okay, and then I'm going to fill my arrows in and stop at this. Okay, so we're stopping here. And wherever we're stopping, it has to be the arrow pointing down. So we go up, 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 and then down, down, and we stop here because it's a downward spin on the 0 orientation. So that's it. So we have 5D, and we count how many electrons we have. 1, 2, 3, 4, 5, 6, 7, 8. 5D, 8. Okay, so now I look. So we have 5. Can you see? This is 3, 4, 5. D 1, 2, 3, 4, 5, 6, 7, 8, and that's platinum. So PT is our answer. Okay. All right. Write the 4 quantum numbers for the following. So SN, that's 10, I believe. This one. So what does it want? 4 quantum numbers. So we need to do N, L, M sub L, M sub S. Okay, so Sn. So Sn is in energy level 1, 2, 3, 4, 5. So 5. It's in the P block. Okay, so remember P is 1, 1. So we don't know. We could, like I showed you in the video, we could list all of them like this, -1, 0, 1. Or if you didn't like that, you could wait. You could wait and fill it out and do it this way, okay? So then it would be -1, 0, 1, okay? So Sn has 1, 2 electrons. So you would fill it up 1, 2. So Sn would have, it stopped here. So 0 orientation. Oops. Okay. And then the spin would be +1/2. You have to do them in order on up, 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 down, 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 okay? Or else you'll get it wrong. Or else you would have thought it was -1 with a down spin. Okay, moving on. Electron paired with the 6f6 electron. So I did this last year too. This isn't a thing. 6f doesn't exist, okay? So 4f, 5f, there is no 6f. So doesn't exist. But basically, let's just, no, we'll leave it. It doesn't exist. But whatever it is, you would just do the same numbers except opposite spin. That's how you would find this electron paired, the quantum numbers. Chlorine with a -1 charge. So the 4 quantum numbers, we have N, L, M sub L, M sub S. Okay, so chlorine, 1, 2, 3. So N would equal 3. Chlorine is in the P block, so it would equal 1. M sub L. So M sub L, okay, would be the -1, 0, +1. If you don't like doing that and then circling the one you choose, do this. Okay, so chlorine. Let's look at this now. Chlorine has how many electrons? So chlorine has 17 electrons, and let's only talk about in the P block, okay? So it has 17 electrons, but we're talking about the chlorine ion, so it has 18 electrons, but in the P orbital, it'll have 1, 2, 3, 4, 5, 6. So it'll be 1, 2, 3, 4, 5, 6. So it'll be 1 and a -1/2 spin. Okay. If that was confusing, okay, maybe do the electron configuration for CO1, like the last one. So this would be for chlorine. Neutrally, it's chlorine -1. I'm sorry, it would be. That's the ion. It'll be 1, 2, 3, P5 would be the last bit of the electron configuration. Chlorine -1, you would add 1 more electron, so it would be 3p6, okay? So you could do 3p6 electrons, so you could think of it that way. So 3p6 is chlorine's ending. There you go. Okay, that's it. We can do one like this so that you know electron paired with. So let's just make a question since this is already done. So let's say, because I think there's one like this on your test. I don't remember. Let's say it asks electron paired with, what was this 3p6? Let's say 3p3. Okay, let's say we want to know the 4 quantum numbers for the electron paired with 3p3. So 3p3, we'll have an N, L, M sub L, and an M sub S. Okay. Okay, so electron paired with that, I'm going to draw it in black now instead of red, so hopefully you'll see it. So 3p, and then we kind of do these together, so it's -1, 0, 1. Okay, and then we have 3 electrons, okay? So 1, 2, 3. So this is 3p3, this one, okay? So M sub L is 1, okay? Plus 1 if you want to add that, okay? So the electron paired with it is that. So instead of doing plus 1/2, because that is 3p3, the electron paired with it would be a -1/2, okay? So that's it. All right, guys, good luck on your test. Be sure to bring the review on test day.